Okay, I can
You
share
want to
my
share?
screen.
You want to share and see what the issue is? Just quickly, couple of minutes, and then we'll get
Yeah.
started.
Okay. Sorry, I think. Sorry, I'm just sharing my screen.
Yeah.
Okay. Do you see my screen?
Yeah.
So this is what I see it. I don't see anything else.
What do you want to see?
So S3 and all.
Yeah, it's there, right? S3. If you go
This
explore one
one.
of these, yeah, click on that.
So this is not completed.
Yeah, you have to complete signing up, finished registering.
Yeah, we need to give the card details.
Card
That is the,
details, yeah.
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 Okay. Okay. I'll do that offline, and then if there are any other
Yeah.
problems, I'll.
So if there is a search bar, right? You can search for any service you want to see there, it will show.
Okay. Okay.
Okay.
So it is paid, right? It's not free.
Some parts of it are free, like free tier is there. So sign up for the free tier. Some storage is to some extent is free. You get some credits, but it's not very expensive. Keep an eye on the billing, that usage and billing. It will show you how much you are using it. But for whatever S3 you use currently, it should not be much. And then when we do some use cases using Glue or RDS things, serverless, there might be some charge, but once you practice and run, then make sure you delete all of those services.
Okay. Okay. All
Okay.
right.
Yeah. All right. Okay. Let me share my screen. And then look at. Okay. So today I want to talk about the streaming. Okay. Um, so what do you think of when you talk about streaming? Anything. So let's have some kind of discussion. What streaming is, what use cases, why we have to kind of.
Like, is it like a dynamic data which is being streaming live, like
Mhm.
is streaming?
Yeah.
So whenever one set of data is being changed, so overall data for everyone who uses should have to change like parallelly. Like
Mm-hmm.
it's a kind of live. Streaming is kind of data streaming.
Okay. Okay. So
Am I able?
everybody, yeah, you can all give your perspective. There's no right or wrong answer. We just want to get thinking, understand, so that we can collaborate and work, discuss together. Ramya, what do you think about streaming? Anything. It's not limited to data. Just talk about streaming. What is streaming?
So I would say the activity,
What kind of activity?
um, like listening or watching or something, or
Mhm.
access the um, internet.
Okay. Close. Yes. Yeah. Interesting. Listening,
Yeah.
watching internet. Okay. Anshu.
So streaming for me is the continuous pipeline of data which you can retrieve. It's a near real-time data which you can listen in, or like it can be audio, video, or even the text, while a big amount of data.
Okay. Yeah. Good. Close. Nasima.
Yeah, so streaming, like I would say, whatever we are, the data, whatever it is generating, like any type of data, we are displaying it, like whatever the data is producing, we are just consuming and displaying it in in live, and it updates like in real time.
Okay.
Yeah.
Nabi.
Yeah, it is the delivery of the uh, content for the internet where uh, kind of stream we see in the form of that allows us to watch something on the over the internet using some
Sure. Okay.
yeah
Good.
streaming works like Netflix or something.
Yeah,
Watching.
exactly. Yeah, nice. Ishrat, it's okay. You can also give it a shot. What do you think of when you think of streaming? Any stream?
When I just remember the Netflix streaming thing.
Netflix. Yeah. Okay. Nice. Yeah. So most common thing is streaming. When you see, you first think of Netflix because you see Netflix streaming, Netflix streaming. So most of us associate streaming. All of us. I mean, it is true. Streaming with entertainment or movies that are continuously live streaming over the internet. Data is continuously flowing. So what is the meaning of stream? Stream is something like flowing continuously, right? Like water is flowing continuously. That's the stream, correct? So a stream is flowing, which means it's continuously flowing. The water, whatever. So same thing when it comes to data. When a data is continuously coming in, it's just a streaming data streaming or streaming data kind of a thing, or you call it live data. All right. So real time, near real time are two concepts that we coin to understand the concept of streaming or to document the concept of streaming, correct? So when you say it's continuously flowing, right? So when you say Netflix is streaming data. What kind of, so Netflix is streaming movies, for example. Streaming, when you say movie, you're watching the movie, it's continuously streaming and you're watching, right? And we know it's happening over the internet. Okay, the streaming the movie over the internet. So there are two things. One, the movie is streaming, and then we are watching the movie. So there are two things here. One is what is the format, what is the type of streaming that is happening, and how it is happening. Correct. So first thing, what we are watching is a movie. So it's a video file, video and audio, right? Together that we are watching. And the streaming happens. So you cannot, video is not a thing that you stream, right? Video itself is again data. So how do you stream over internet? It has to be in bits and bytes, right? So only the bits and bytes, the data that you can stream through internet, correct? So video and audio files also is kind of a data that can be streamed or pushed over the internet or sent over the internet, transferred over the internet, and then you are watching. Now, what is the difference between batch and stream? So let's say I send a packet of 10 bytes, okay, or 100 bytes or 1 MB, a packet, you receive it, and then you open it and see it, or you process it, or you watch it, okay? Initially, you must have seen like buffering happens. Why was the buffering happening? Because you couldn't receive the data in time, or you couldn't process the data that is coming in time. So you cannot watch it. So there's a break. In that break, it's still trying to receive the data or process the data and then show you the video or audio. So that's why it says it's like buffering, right? The speed is not good. So you're not able to get the data at the speed you need to watch the movie or whatever. So that's the streaming data that is coming in. So streaming can be, when you talk about Netflix, we talk about just the movie that is streaming in, but what it actually is, it's a streaming data of audio and video files. Again, it's bits and bytes only that gets streamed over and gets the player converts it into a movie for you, right? So in streaming, you have two things. One is the continuous flow of data, and then the other is the over the internet bits and bytes that transfer, the speed at which you are sending the data. These are two things that form the main components of the streaming. What is the difference? So when you say, I say send a packet at 1 MB, I watch it. Okay. Then the next packet, suppose for example, we are putting the entire movie into batch processing that we did. Right? We all know about batch processing, right? We are processing scheduling. So the same batch, I split the data because I cannot send the 2 GB file completely in one go. So I cut, slice and dice, send 1 MB packet, and then I will wait for 30 minutes, send another MB packet. So what will happen? You will watch 1 MB and then you have to wait for the next batch to come in, right? So only then you can watch the next part of the movie or whatever. So let's say from 30 minutes, I send it, every 5 minutes, I send the packet. So I can take it and process that 1 MB or 100 MB, whatever, 10 MB file. Then I watch it, then wait for 30 minutes or 5 minutes. So slowly I'm reducing the packets, the time between I send the packets of information, right? So let's say I come to 1 minute. So I'm getting 10 MB file or 10 MB data. I take it and let's say I need it like 30 seconds to process it and view the file. So the first packet has come in. Okay. So let's go here and say, okay, so I started the streaming at 10 a.m., right? And we don't know how many packets or how much size it is. So some streaming platform is sending me the movie in packets. Okay. So the first packet, let's say, for example, 10 MB file. So I received it at 10 o'clock and say the processing took 30 seconds. Correct? And I'm watching the movie. And say the movie, so this 30 seconds, I'm continuously, for example, just assume that as it is processing, I'm watching the movie. Okay. So 30 seconds I have watched. Now there is a 1 minute delay in each batch. Okay. So normally batch is 1 hour or 30 minutes you run, but for simplicity's sake, I'm reducing the time of the batches from 30 minutes or whatever. So if I say 30 minutes batch, so the next packet will come at 10:30, right? Another 10 MB. So now I have watched just say 30 seconds of movie, and then I have to wait half an hour for the next 30 seconds movie. Correct? Is that a fair assessment?
Yes.
Yes. Okay. So now that is extremely ridiculous, right? So I cannot watch a 30 seconds movie and then wait for another 30 minutes for the next one. So what we want to get faster, right? Receive more sooner, more frequently the files. So then I will say, hey, no, this is not possible. So let's say, I say, okay, I will send you in every 10 minutes. Okay. Now I watched 30 seconds, then I have to wait for 10 minutes again. So 10 minutes is also ridiculous. I cannot wait for 10 minutes, watch 30 seconds, then wait for 10. It will take me the whole day or more than a day to watch the movie. So let's say I give 5 minutes. So 5 minutes is also plus. Now let's say I'll send every 1 minute. Okay, let's see what happens. So you sent me 1 minute and processing took 30 seconds. Okay, so I watched the movie at 30 seconds is done. Then the next packet is coming in 1 minute. So how much time is in between?
So 30 seconds we have to wait, right?
Yeah, so
30
there is a 30
seconds,
seconds delay,
wait,
right?
delay.
So
Yeah.
that 30 seconds you keep buffering, processing, kind of, it's still trying to receive the next packet of data. Okay. So now what we do, I don't want to wait 30 seconds. So let's go into, I don't want to, so the minute is not also not feasible for me to get the packets. So I want to get into seconds. Okay. So now I will say send me every 30 seconds. So now I receive this packet. I watch this 30 seconds. And then there is a next packet that is coming in the next 30 seconds. So I will start processing this. Okay. So once I have watched this, the next bit can start. But again, there is a caveat. There is some processing involved. So the moment you get the packet, you cannot start watching, right? So your player has to process the data. So then again, it will go into buffering. It will say processing the video kind of a thing. Correct? Now, so I don't want that as well. So let's say the processing takes 15 seconds. So now what I want a 10, 15. So every 15 seconds, I need to get one packet. So now I got this. Let's say I started watching this movie. It's taking 30 seconds. But by the time I watched 15 seconds, the next packet has come and it has started processing. And then by the time I watch this, the next packet is ready. So for viewing. So immediately it can continuously start. You can start viewing the video continuously. Correct? So that there is a overlap. You're watching 30 seconds, but within the 15 seconds, the next packet is ready. So you still have 15 seconds left from the previous packet that you are watching. And then the new packet is already processing. So by the time you finish that, this will continue playing for you. Right? Guys, getting this?
Yeah, correct. Yeah.
Yeah. Okay. So come on, guys. You need to talk. Otherwise, I don't understand.
Okay.
Your not. Please. So what are we essentially doing, right? So we said we'll start. We are all still talking about batches, right? We're still batches only. So we said we'll start every 1 hour batch or every 30 minutes batch, right? We started with 1 hour, then we said 30 minutes batch, then we said no 10 minutes batch, 5 minutes, 1 minute, 30 seconds, right? So we are actually, what we are trying to do here with the batch?
Like
What are
actually
we-
processing the data, right?
Sending,
Continuously is processing the data.
Yeah, but with the batch, what are we trying to do here with the batch time? What are we doing with the batch time here? We said first we'll start with batch, every batch 30 minutes. Then we said, no, that will not work. We will do a batch every 10 minutes. That is not working. 5 is not working. 1 is not working. 30 is not working. So we said we need to have a batch at 15 seconds, right? So what are we doing with the batch time here?
Batch time we are reducing it, right?
Right,
Delay time,
exactly.
yeah.
So we are trying to reduce the time between batches. That's the exact point. We are trying to reduce the time between the batches. So the normally batch job, whatever we have processed, normally batch jobs run daily. So once in a day, or twice a day, or thrice a day, or hourly. That's mostly if you say batch, that's what mostly jobs run. There might be some like 30 minutes, or 1 hour, hourly, or 30 minutes batches, but so those are not very frequent. So very less use cases where you use that kind of batching, but yeah, it is possible. The point is, so if we need every 30 minutes the data, which means that we need more frequently, the data that is coming in, correct? So we need kind of data processing more frequently. We need data as and when something is coming in. So slowly we are reducing the time between interval between the batches. Okay, so as we go reducing the time, it will come to the point where you cannot differentiate between the batches now. Okay. So now if you say I am having a batch every 1 second, it is almost like the data is coming in continuously, right? Every 1 second. Yes, you're getting processing, getting processing, getting processing. So when you look at it at a highest level, you will see like, hey, the data is continuously coming in, right? 1 second. Correct? Or half second, 500 milliseconds, 100 milliseconds if you process data. Isn't it something like that is coming in continuously? You wouldn't say that? Would you say, hey, it's a batch process every 1 second?
Yes, for every 1 second, a batch is processed. Yes.
Yeah, it's a batch at every 1 second. But if you look at it, how do you see? Isn't it coming continuously?
Like
Yeah, it's continuously.
Yeah.
Right. So a streaming process is almost a batch which is very frequent, or a micro batch. So data will come in very small batches, micro batches, but very frequently. Let's say a second or in milliseconds, the data is coming in as a batch. But at that point of time, in that millisecond, it's still a batch. But if you look at it at a higher perspective, if you zoom out, okay, if you zoom in, it will be a batch at that millisecond. If you zoom out, it will look like it is continuously flowing because it's happening very fast. The batches are happening very fast, very frequent. So that's how you continuously process. Even if you're watching a movie is not that is continuously running, right? You know that. You know the frames. There are 24 frames per second or 32 frames per second, correct? And then you look at slow motion, which means that there are less frames in that second that you are watching. It's a continuously changing visuals that you see as a streaming data, continuous video data. But it's what it actually is, number of frames or images per second that you are watching, right? So 24 frames per second. If it is a fast forward, like more frames per second. In slow motion, it is less number of frames per second that you are watching. So same thing, you apply to data. The processing happens as a micro batch very frequently. That's streaming. That is what you call near real time or real time. Now look at the use cases. One of the use cases we have been talking about is again streaming, movies or videos, audio, whatever. That is live streaming, which is over the internet. We have streaming data, correct? Audio or video. Now, in a sense, that is data. But when you say pure organizations, even Netflix, for Netflix, it is the data, audio and video. That's what it does. So for other organizations, let's say you have, let's say, two use cases, right? So one is where we use this kind of data. It's sensors, weather, sensors is basically aircraft or whatever here. And credit card transactions. Anything else you can think of? Network logs. Okay, so these are the use cases. Let's talk about, right? So first take this credit card transactions. So why do we need near real time or real time data in this? Why can't we have batch? I think we briefly touched upon in the introduction sessions earlier. So let's say I'm doing a credit card transaction. Okay. What happens when I do a credit card transaction? Is something happening? Somebody is processing, somebody is approving, or
Yeah.
no? It just goes.
Yeah,
Now
as
we
soon
should
as
be
the
knowing, right?
transaction
All
is
of
Yeah, as soon as the transaction is happened, it will be processed at real time, and that should reflect in the system.
Exactly. So, though your credit card account or statement does not reflect immediately, but the moment you tap the card, it's already be so when you see it is processing there, by the time your transaction is already processed, it is checking against your limits, it is checking your card is blocked or not, it is checking if it is the geo location is correct or not, it is checking your ML models, it is processing, it's going into your machine learning models to see the pattern behavior to understand is this a right transaction or not. So all of this will happen, right? So otherwise, let's say if you are doing a batch process, hey, I will go and give my card, I will buy something, that data will go and sit. After half an hour or 1 hour, they will process and see that card is declined because it is already expired. Then what will happen? You cannot take an action, right? So already the transaction has happened, you have purchased something and you are gone. So the merchant cannot track you and say your card is declined, give me the bag. Correct? Guys,
Yeah, that's correct. Yeah.
Yeah.
come on, talk.
Yes.
Correct, right? So what is the need? The need is the moment you give the card, it has to be say validated immediately. First thing it has to be validated is the card active or not. That has to be validated. Next thing, then it will do you have the credit limit or not, right? Let's say you have already used up all the limit and then you are again buying some $1,000 or $2,000. So which is credit limit is not there. So that has to be validated. So next thing, whether it is a valid transaction, right? So is the right person that is doing the transaction? But how will you know he's the right person? Because you're not there. You can't do an identification of the person right there who's doing the transaction. So then you will put an ML model there, machine learning model. The transaction goes to a machine learning model. So what does the machine learning model do? I'm just trying to tell you my guess just for an example. Let's say I am doing the transaction here. Maybe it can be an online transaction or a physical card transaction. Physical card is okay. So let's say I'm doing a physical card transaction here, say in Dallas. Okay. Now at 10 o'clock. Now at 10:15, somebody is doing the same physical card transaction in New York. So is that valid? I cannot have the same card physically at two different places in just 15 minutes, right?
Yes.
So I
Yeah,
cannot
that's
be
correct.
in Dallas and New York in 15 minutes and to use the same card there. Or somebody, so that is purely say it will not go through. It will it will put an alert, fraud alert immediately, and then the transaction will block or they'll send you some confirmation that you have to confirm on your registered phone. Yes, I am doing this transaction or whatever kind of a thing. Or if it is doing online. So I bought here from this IP address or geolocation something, and somebody else is using the same card to buy online somewhere else. So that will also like try to be get a fraud alert. So these kind of things should happen when you are doing the purchase, before the purchase is processed or accepted, right? So that for that reason you need live data, streaming data, real-time data to process. You cannot have it in the batch because by that time the transaction has happened. Whoever has purchased, so online is okay. You might maybe they can go ahead and cancel the transaction, decline that whatever. But if it is a physical transaction, then it's already happened, right? The goods have been bought or purchased, kind of a thing. So that will not work. So for that reason, you have to have a real-time data processing, correct? So for that, the moment you put in transaction, it will go through all of these checks and validations and ML models, machine learning models, AI models to make sure that the pattern or the behavior, the buying pattern or the credit card usage pattern is consistent. There's nothing completely different or new that's happening that will flag the transaction as fraud, right? So that's one. The other one is, again, say network logs that are coming in from various servers to see if all of the servers are behaving correctly or not. Something is continuously, the logs continuously, they'll stream all the messages coming in the logs, errors that are being thrown in the logs. So that's a continuous stream that is flowing. As and when it is logged, it continuously comes and we process and we look at something is faulty, some servers are not responding. So all of that process we can do. Sensors, again, IoT devices. In the aircraft, for example, there will be multiple places, but in the aircraft, there are like thousands and millions of points, sensor points that keep continuously kind of send you the what you call metrics every second or every millisecond. They keep sending the information. What is the temperature? What is the pressure? What is the wind speed? What is the vibrations? All of the sensor data they keep transmitting, right? And as a IoT devices, they have sensors. So those sensors keep transmitting those points. Okay, temperature, pressure, wind speed, all of that turbulence and fluidity, whatever. I don't know what all the parameters, but the kind of altitude, difference in the speed, the acceleration, the angles, whatever. So all turbulence, everything, they kind of keep sending those points, keep sending the metrics, and there will be some systems that are continuously receiving and processing the data to see if there is something that is odd or behavior something different, so they can predict if there is a time to fail. So based on those things, say let's say some vibration in some part of the aeroplane is increasing over the time, then based on that they can see, hey, this part is going to fail at some, they can project and predict time to fail, so that they can do predictive maintenance. So they can go ahead and check it and remove and replace, and then wait or repair or replace, then wait for it to fail. So all of this helps in the predictive maintenance. They can accurately predict the time to fail, when this particular point will fail in future, based on all of those IoT sensor data that you process in flight, right? So that is another use case. Weather is another use case. You have to actively track all the points of pressure, humidity, temperature, wind, to predict the weather, whether it be sunny, what temperature it would be, until we are predicting almost like 10 days out. Pretty decent work of predicting the weather right now. So all of that, again, based on sensors, based on data that is being continuously streamed and being processed in the weather models. So all of that are the use cases. There are very, very few, but there are more and more. Just like that, the sales data or the revenue or whatever that they want to do, a live streaming, live processing, continuous processing of the data if they want. So they do this stream processing. Okay. Now let's see how Spark streaming works, right? So basically we have something called, so we have seen the batch data, correct? Let me, 1 second, let me log into this. So we have seen the batch data, right? Processing batch data.
Yeah, database, right? Yeah.
Yeah.
Correct. So similarly, we want to see how we can do the streaming data in Spark. So when we do batch data. So how are we doing it? So there is a data, something in the files. We are going and reading those files, processing that data into tables, correct? And then when you run the job, it will read the files, it will process it, put it into the table, transform, then put it into aggregations, gold layer, and all of that, correct? Now, when there is a streaming data, so how do you handle streaming data? So streaming data in Spark, right? So everything that is data that is coming in will be added in the memory. So we knew, right? So we had all data in the memory, whatever data frame, whatever file it has read, it will put in the memory as a data frame. So we can do transformations in memory, or we can do register as a temporary view in the memory and then do SQL and all of that, which means all the data is in memory at that time. Are we all agreeing on that?
Yeah, Karan.
Yes.
Okay. So let's say this part here, the first block, right? So this is the data, this one. Okay. So this is the data, the first one. When you have starting at time 0. So this is the data in memory. Now there is a stream coming in, data stream. So let's say these are credit card transactions that you are doing. You are continuously on a buying streak. You are going shopping and you are buying, all the items. So this is what you bought, and then you bought a new item and you paid with the card. So this transaction is coming in. So this transaction will come in the memory and get added to the same table. Then another transaction is coming in. It will also get added to the memory. So streaming is implemented as a unbounded table, which means there are no bounds. It keeps continuously increasing in memory. Till that point, you define how much past data I want in the memory. Okay. So for each transaction, let's say for each batch or for each customer, for example, let's say I want to have only 2 hours of data or one day of data in memory for each customer. You can define whatever you want to based on the time to live or the window kind of a thing. But so the data is coming in continuously with the unbounded table here. So at this point, you have 4 transactions. Now at this point, you have 8 transactions. Right? So that is how the data stream comes in. And then all your job will process it as same as a batch. Okay. But only thing is every time it runs, it will have more data to process. So trigger interval, say every 1 second you are triggering. So new rows are appended to the input table. Okay, so this is the input table. So new rows are appended every second, whatever data that is coming in. And first, say maybe you have 10 records, then 2 records came in, so total 12 records, then 3 records came in, so total will be 15 records. So it will be in the target. After processing, you can again put as append mode or update. Okay. So complete mode is entire updated table will be written as a external storage. Append since last trigger or written to external storage. So there is no change in the previous rows. So for example, these transactions will not change, right? So whatever has happened, these new records will come in, they get processed and get appended to the output. Unless if you are doing average kind of operations, aggregate. So if I want to do average, as soon as new data come in, so you have to combine old and new data and take the new average. Correct? So average will always look at all the data in memory. So we will go through it, how it, you will see how it changes whenever we do. So these are the simple kind of how the streaming is happening in the Spark streaming. Okay. As and when the data comes in, you will process this. So let's say I have a sample data. So how for a streaming job here, what you can treat as a stream? You can use the files that we processed, right? the same files also you can use it as streaming files, which means, hey, every 1 second I keep getting new data as a stream. So you pick up that file, that will become your new data. Okay. Or you can use your table also as a stream. As and when new data is coming in a source table, you pick up in the streaming live data and then process it. Or you can use some streaming tools that are have like Amazon Kinesis, Kafka. So these tools also keep continuously streaming the data, new data, so that you can use those also as a source. So for example, to just show how streaming works, we have like this some Spark or Databricks gives you some files that you can, as an example, you can process this and see how streaming works. Okay, let me go here. Compute. Create compute. Okay, so there are a couple of data sets that you can use, like JSON files as the streaming. But then, as you said, you have done the batch process, right? So the streaming process will also work very similarly. So when you say spark.read.json, correct? That's what you used. Let me go here and see JSON file parsing. This is your batch job. You said spark.read.json, correct? So this is your batch, read.json. Now, when you go to streaming, so how do you read the stream? Is simply spark.read stream. Instead of read, you will use read stream. Okay. And then same .json input path. And there are a couple of new options. Basically, you can give schema if you want to read the schema. Like this is the same thing as you had in batch. So this option is new for streaming, because you want to see how many files you want to trigger take per second. So okay, so here max files per trigger. So for each time you trigger the reading of the stream, you take one file. So every time it goes back and reads, it will take one new file and then process it. So that's what we are setting the option here. Max files per trigger is 1. So spark dot read stream, read from this path, that stream, okay, of files, and then each time you trigger to read, just read one file. If you don't put this, it will read all the files in one go in the first time it trigger. That's it. It will be like mostly like again batch only. But if you want to write in a stream, want to simulate that you are going back and reading one file at a time as a stream, then you can use this option. Now, while the data is streaming in, so for example, you have done aggregations in a batch job, which is there in the memory. You ran the SQLs to create aggregations, right? So same thing here. You can still do in memory. You can do your aggregations, group by aggregations and count when you are still continuously reading the file, reading the stream. So every time the group by hits, it has to take all the information, right? It cannot take only the new information to group by. You know how group by works. Group by will work based on the entire data, right? So group by is basically counting how many of each type is there. Okay. So
Yes.
let's say I'm streaming data of fruits, right? So at time t1, I say I got an orange, I got banana, I got apple, I got orange, and I got banana and I got banana. Okay. So at this time, so if I do group by, what I will get? I will get orange. How many? I have 2. Banana, how many I have? 3. Apple, 1. Correct? Is this correct? Group by will give me this, correct?
Banana
Yeah.
to orange one. Yeah. Okay. Yeah.
That's it, right?
Okay.
Yeah.
So at
Yeah.
T1, this is the data that has come in. Now, after say 1 second or another second, so T2, now the new data is coming in a file. So in this file, I have banana, orange, orange. So now I am running a group by. So if I do group by only on T2, okay, so I will get banana 1, orange 2, right? But what about this one? We forgot about this data that is already there, previous data. So if I say, hey, how many oranges did you get? You will say, just now I got only 2, previous one I don't know. All right, so you have to give the complete information of all the data. So at T2, what it does is it actually has to take T1 plus T2 data when you do group by. So then it will say banana here 3, here 1. So you will get 4. Orange, you get here 2, here 2. So oranges 4. Now apple you didn't get in T2, but there is still in T1, that's 1. So this is what you will get, which means at each time when you do a group by, it's aggregation. So aggregation will always have to take the complete data in memory or in the window context that you are trying to do, and then do a whole operation on that. You have to recalculate everything. You cannot just do incremental stuff. Okay. So so that is why for aggregation, this window you need to have. So you can do on this streaming data, whichever is in memory, right? So here in memory, I already have this in memory. I already have this in memory. So it will take all of these and then do the aggregation. So as and when you get more data, your aggregation will keeps changing. Okay. This you can also do the CSV files and processing all of this data. You can write these things, create, and then do the processing just like your batch process. Now let's see. I have Databricks will provide some sample data. You will also have at the same path Databricks data set structured streaming events. There will be okay. So you don't need to upload these files. These are already provided. Everybody or for all of you, you can. This is a standard path or standard location where Databricks will provide some data sets. So have you? I think we talked about this briefly. So dbutils.fs.ls, right? So we said Databricks utils file system list. List is like show all the show all the elements or the files contents of the directory or path, right? So if I use the same, I can go and check whatever Databricks provides you. I'll just go here and say what is available in the structured streaming. So there is only one thing called events. That's all. Other than structured streaming, what are the data sets that, if you go one folder up and see what does Databricks data provide data sets. See, all of these data sets are available for you to explore. Okay, you can use these data sets just as is to do your practice. So all of these data sets are there. Do we have all of this here, or maybe let's go and see. I think on the GitHub also they will show you sample Databricks data sets. AWS or Azure, I think it's same. Yeah, so these are all the data sets that are available mounted to DBFS. See this one. These files, you can use Databricks utilities, DB utilities. If you go to reference, so these are all the modules. FS is a file system, and commands you can use notebook.help, file system.help. It's just like, if you want to see what commands, you don't need all of this, so don't worry about it. Mostly you will just use ls and head, and so these kind of things, head and ls. If you want to create your directories in DBFS, you don't do much of this, so don't worry. Mount and mount you can, but if you want to, you can look at it. Head is just if you want to see the header of the file, some sample data from the file, whatever is the file. Okay, let's come back here. So you have all of these data sets that are available. So you can go and explore what are the data that is available within each. So if I see airlines and see what are the files. So these are all the files. So what kind of data it has, we have to see basically what kind of data. You can go here. What is this? When you say this is part 1, 2, 3, 4, 5, 6, okay. This is again a directory. I think these are the Parquet files. Okay. Go here, check what is there in this directory. It's not there. Oh, I think this is the file itself. Okay. It doesn't have an extension. Yeah. So this is the file. So since it's not a JSON or CSV, I think it's most likely a Parquet file. So we'll see how to read those files and all. But if we go back to our events, in the events folder, whatever files I have, it's a JSON file. Okay. So if I can take one JSON file, event/file0.json, and then I am doing spark.read.json. So you can actually, this is same like what you did last time. You can say file path, right? File path equal to, or just, no, not this. We have read using okay, just this. Okay, so this JSON file has just two elements. It's called an action and a timestamp. Okay, open, there are two things, I think, open and close. There are two actions, open and close, with timestamp. They just keep repeating in the file, just some junk data. Just to make sure you have the context. In each file, you get some entries with open and timestamp, some entries with close and timestamp. Okay, that's how the JSON file is. Let's say dbutils.fs .head. Okay, and just take this file name, put here, and then display this and see. Okay, so this is how the raw file looks like, JSON file. We talked about JSON files, right?
Yeah.
So truncated to first this types. Okay, so it starts like this: time, action, one line. Next, time, action, another line, time, action. That's it. That's all it has. A file bunch of just time, action, time, action. That's it. This is a timestamp, and then this is an action. So this is the file structure, JSON structure, simple JSON with two elements in each line. That's all. And this is what we are reading using Spark data frame. So it has parsed the data into two columns, action and time, like this data. Okay, now what we are doing here, we are trying to read that events folder, this folder, which has all of these files. Okay, 50 rows, 50 files you have, or maybe we have more. I don't know how many rows, but so all of those files we are trying to read as a streaming data, one file at a time. Okay, first read one file, process, go back, read another file, go back, read another file. Like that we are doing in a stream. Instead of reading dot read JSON, we are doing read stream, and then we are giving the same path to the folder, events folder. So inside the events folder, we have all of those files. And then we are giving just two, this is the structure we are giving JSON schema, struct field. One is a timestamp type, and the other is a string type. One is a time, another is string. We are using JSON schema. You can also set without schema also, I think. Read stream option, max files per trigger is 1. So each time you treat a sequence of files as a stream by picking one file at a time. So that's how you process this. Now you say display. We are doing this data frame. We are doing group by. So group by action dot count. So what is the action? Action will have open or close, right? So we are just counting how many are open and how many are close every time you process continuously. So when it is a stream and then you are doing this, you will see this continuously, it will go up, right? Every time new data is coming in, so the count will increase, correct? So that we can see when the data is streaming, when we are processing the data in stream, how the counts are increasing. So this is the same with another the events data set called Amazon. So I think we need to put the files here. We'll come to this. So let's first go and run this and see what is happening in the streaming here. Okay. So I will run this. So if I run this, there's a concept in Spark, right? When you do anything in Spark, basically how Spark processes, and this is very, very important, pay attention. There are two types of things that Spark does in processing. One is transformation and the other is action. Okay. So there are transformations and actions. Spark processes in a lazy evaluation. You have to be very comfortable with this term. Remember, it's called lazy evaluation. Okay. So it will not run everything when you run it. It will only create a mental map of all the things it has to do. We will discuss that in detail, but remember this. It will only create this is the plan. I have to do these things. That's it. These are all called transformations. Now, when there is an action on that is when it will go and execute that plan and give you the results. So there is a transformation, there is an action. Okay. So this read stream is actually a transformation. So it knows it has to read from this path. This is the schema and this is all of this. But unless you do a display, it will not trigger this. Okay. So what we will do, if I run this now, okay, nothing happens. It just says just now 1 second. That's all. Now, when I do display this streaming input DF is now. So now it will start executing this job, streaming DF. Stream initializing. See, now it is initializing this stream. So you get one file, you process it, and then you display the count. So you can see here input versus processing rate, what is the batch duration, what is the aggregation state, and see here open 1469, close 531. These are the elements in the file. Now I'm not doing anything. It's still running. Okay. It's still processing. One file is done. See, the count is increasing 2,500, 3,400 to 5. So every time it's processing the file, it's updating the counts. So it's still running in the streaming job, real time. So until it does all the files. And then you have to explicitly stop a streaming job. It will not stop. It will continuously try to see if there are any new data coming in. It continuously try to poll for the new data. So streaming is real time. So it keeps running forever if you don't stop it, or if there is an error or something like that. So you can see what is the input rate, 176 records per second. Processing rate is 162 records per second. Now processing is increased, input is 162. So you can see where this is important is you have to see how your job is processing so that it does not choke. Let's say you're getting more data than you can process. So the data will be queued. It will choke. So you have to either increase the processing power so that it can process all the data that is coming in, or you reduce the speed at which you are receiving the data so that your processing will match with that. So you have to make sure these two are in sync. Otherwise, your job will go like the data will keep coming on, piling up, and then it will fail at some point because of memory issues or processing issues. Okay. See, now you have 12,000, 11,000. So it's still processing the files. and then you can see. So these two has to be in sync. If one thing just keeps going up, then it will fail. It's like you can see at this time, 1048, 1049, 1050, 50, 51. It's doing how many distinct keys at each aggregation state, and what is the count. So you can go here, visualization you can do, and then see, open, close like this, bar chart, just do line chart, action. So this is close, this is open. So at each point, you can see how these are increasing. You can also see that here. Okay, so it's still processing, still getting the count. But you get the idea, right? So that is how the processing happens for each window stuff. So did you understand what streaming now means?
Yeah. What question, Nagaram? When it processing the files, multiple files, right? It picks the file based on the timestamp when it received and the process sequentially, right? How it decides what file to
So now
process.
you have given the directory, right? Okay.
Uh,
So in that directory, it will know what files it has processed, what files it has not processed. So it will pick up only those files it has not processed. In the live, if there is on the cloud, if you have files, so there is something called autoloader. Okay, Databricks uses, where if you give the option of format as cloud files, it will go, say for example, S3 bucket. We will do that use case also. So as and when the file is coming on the S3, it will automatically pick up those files and process, and it will look for new files that are coming in. So it will not process the same file again. It will give you exactly process once guarantee. Okay.
okay.
So that
it always like sometimes when the files are came in already arrived, right? And when the processing is there is some processing delay, but the process should pick the file when it came
Yes.
based on the timestamp, right? The latest timestamp.
Yeah,
when the file came.
timestamp. It will know
Okay.
which file it has processed, which file, even if it has come. So there is a out of sequence guarantees also it will take care of within the window. All of that is built in. You don't have to again go back and write and make sure which file is processed, not processed, go and pick this file name and all of that. So once you have set up the job with a folder or a bucket in S3 or any cloud location, it will keep track of what are the changes that are happening on that storage location. Which files have come in, which files have processed, which files are not processed, which file came in late. So all of that it will automatically take care of. Okay. Yeah, so this is still going on. You can see it's running 258 records, 263 records. The count is going up. So everything is in memory, right? Now, let me stop this. So that is stopped the job. So this is another data set we have. Okay, like we did yesterday, tables.amazon. So if you have, where is that Amazon cloud? Where did we go? Okay, so these are Amazon files. I will give you that also location. But you can go here, file store, tables, Amazon. Do we have this? This was the old one. Events. Oh, not database, data sets, right? Okay. Catalog, table, let's say Feb 25. Under this, I'm creating another folder called Amazon. And then I will go here and go downloads, Amazon data sets. I don't know how long it will take. Okay, so I think all the files are done, right? So we can go back here. Okay, so all of these files are available. I have uploaded this files here. Now I will use this location to process. Again, create a new streaming data here. So what I'm doing, creating the structure with ID, name, category, subcategory, image, link, all of this part of that file. Okay. And then display from this, create these tables, and then we can do a checkpoint. So we will revisit this. What is checkpoint? Why do we need this later? So this part we'll touch upon, but at least for now, we can just say how we are reading this and display streaming data frame. From this, okay. So let's see here. So streaming data frame, and then this is display. So I'm running this. Read stream. These are CSV files. I've given schema, and then there are options for the schema files. Per trigger, again, one file at a time, and then load, and then I will do display. So it will go initialize. I'm not doing any aggregations. So it just says 1000 plus rows. So it can only show 1000 here, but it keeps reading and adding more data here. So you'll only know when you do the aggregation. So since the ID it has not found, it is given null, but main category, subcategory, image. So all of this, it is reading, but I think it is shifting. So we'll have to check why it's not, properly parsing the data. Okay. See, this is the image actually, not the category. So there is a data shift that is happening. So there is no name here, category and subcategory. Subcategory, main category is bags and luggage, subcategory is travel accessories, something like that. So that we need to check how it is processing the data, parsing the data. Okay. If I don't say, let's stop this. So if I do infer schema, it's gonna take a very long time because very huge files. So that's why we provided the schema here. But again, we have to look at what that file is, how we can parse that data. Open. And basically all of these files should have the same structure. Okay. Only then that will work. Otherwise it will throw error if each file has a different structure, different fields and all of that. Yeah, let's see, open all appliances. Okay. So this is the structure. So now as you can see, there is no ID in this, but we are trying to give ID as a schema. So that's why it's not able to parse it properly. Okay. So this is the name. And this is the category and this is the subcategory. Okay. So let's try that again and see if we want to remove the ID from this. Okay. Once I removed ID. Then run this. Okay, see now you get the name in this. So main category, subcategory is here. So it's image is here, .jpg, link is here. So everything is perfect. Pass, right? So this is how you need to troubleshoot. If you are not seeing data properly, what is the issue? What is the source data? How does it look like? How are we giving the schema? Is there a schema mismatch? Then your data is distorted. Okay. Basically, it keeps growing data. Then you can go and create this data. So what we are doing here is every time from the streaming data frame, so we are grouping by main category. Okay. So what is the main category? Is this one, bags and luggage. So every time there is a main category, based on main category, we are doing the count. How many items are there for each main category? And then we are writing that stream. So once you read the stream, streaming df dot write stream. So we are writing it to a delta table, just like we used to do batch, right? Streaming df dot write. So here, instead of write, we are doing write stream. And then there are a couple of options that you need to, a few options you need to provide specially for streaming. So output mode, as we have seen, whether it is complete, where it will overwrite everything or append or something. And then there is a checkpoint location. It's very simple concept is just to create a temporary folder. You must have seen every time you process, even when you are downloading a huge file, you will first see some temporary file being created. Once everything is downloaded, then you will see the new file and the temporary file will be removed. So same thing, there will be a checkpoint, a new folder, temporary folder directory, where it will store the details or the processing state, what it is processing, till which point it has processed, so that if it is a failure, it can go back and check where it has failed and where it has to restart. So for now, I think you can ignore this, okay, and then say use this checkpoint, because I don't want to complicate all of this thing. It's a stable name. Okay. So everywhere you see checkpoint directory, right? So here we are creating one method. Okay. What it will do is it will just generate some random folder name. Okay. temp slash delta demo slash checkpoint, and then it will add some random number so that every time you run, it will take some new directory, so that each data frame or each stream will not conflict with other. So two streams should not point to the same checkpoint directory, right? Otherwise things will get messed up. Each one should have its own temporary directory to know if you are downloading 10 files, 10 files should have 10 different temporary folders, right? Otherwise, if all of them are writing, how will you know which file is downloaded to which point? So basically to do that, we have created one method here to give one random number for each time you're creating an option or writing the checkpoint directory. You can remove this or put your own some path like this, but let's see. So we are interrupt this. Okay, so we are reading this file. So let's say we want to create these things, and then I want to create Amazon products raw table where I am writing this streaming data frame. Okay, what is streaming DF? Streaming DF is all of this data. Okay, as and when it's in the streaming window. Then I'm also gold, we are doing some aggregations, and then we can display how the aggregation count is increasing, just like we did in the previous method. Let's take this some other time. I don't want to put you too much on this, but at least you know, right? So this folders, you can go through this, what is streaming and how, at least with the given data set like this, how the streaming works. Then we will continue. We'll keep touching some of the Databricks stuff and then some of the other AWS stuff every week, AWS or Azure, and then until we get into the other tools. Okay, so there are some more concepts, advanced concepts that will be coming up. So I want you guys to be very clear of what we are doing here in the basics, foundations. Okay. Any questions before we wrap up today?
No,
Good
not
from
from
my
side.
side.
Okay. Yeah, so I will publish the notebook, both yesterday's, today's, and the video recording some by afternoon today sometime. You guys can go ahead and do the practice. And please make sure you provide all the assignments as soon as possible. And then we'll also do some streaming assignments, some S3 assignments as well next week. So things will get moving a little bit faster, so you have to be ready. Okay. We
Okay.
don't want to keep this doing forever. So we have to increase, change the gears now.
Yeah, Harun. And also, may I know where can we learn more about like PySpark? Because I had some difficulties with the PySpark. So like each and every time I have to ask for the search for the Googles for every thing. So where can I get to know more easily about PySpark?
PySpark is basically, it's all in
Yeah,
Databricks
online,
documentation.
but anyway, but
Yeah,
it's a bit
Databricks documentation only. Otherwise,
okay.
see, it depends on what you want to learn, right?
Okay.
Let me stop the share here.